where are the 4 bytes available in the memory. So it will try to, let's say the total size of the memory is 100 KB. So my system will try to figure out where are 4 bytes available for allocation. So this, hi all, this is me Karan. So in this particular lecture, we are going to talk about memory pool. What is the idea behind memory pool? In what kind of cases we should use memory pool, and what kind of problems memory pool can solve inside our system. So I'll try to divide this entire lecture in 2 parts. First one is where I'll try to explain the theoretical idea behind memory pool, how do we implement memory pool, and then in the next lecture we'll try to implement memory pool using C++, and we'll try to compare the performance of memory pool with normal memory allocation techniques. So let's try to understand the core idea behind memory pool. So let's say inside my system I have one class X, and inside my system I create the object of this particular class very frequently. For example, let's say in 1 second I create 100 objects of this particular class, and at the same time I delete all these objects within that same second. So what will happen internally is I'll try to allocate the memory to the object of this particular class using new keyword. So what will happen is new X. So let's say this particular operation takes, let's say, 2 milliseconds, and within 1 second I'm gonna create 100 objects. So in total the creation time of these 100 objects will be 100 into 2 milliseconds, which is 200 milliseconds. And at the same time I'm also gonna delete these 100 objects within that same second itself. Let's say deletion takes 1 millisecond. So total deletion time will be 100 milliseconds. So in total I'll be allocating almost 300 milliseconds out of this particular 1 second to allocate and deallocate the memory to these 100 objects of this particular class X. So this is kind of very huge time, and if I'm doing this very frequently, that is again next second I'm gonna create 100 objects and will delete all these 100 objects, and then again next second I'm gonna create another 100 objects and will delete these 100 objects again. So this entire process is gonna take very long time, and because of this there can be latency issues in my system. So instead of again and again creating the memory using this particular keyword new, what I can do is when my application will start, so at the startup itself I know that at a time I'll require at max 100 objects. So what I can do is I can allocate the memory to, let's say, 200 objects inside a pool. So what will happen is when my application will start, at that time I will create the memory to 100 objects of this particular class X. So let's say the total size of this particular class is 4 byte. Then what will happen is I'll create the memory for first object here, second object here, third object here, fourth object here, and likewise total memory will be created for 200 objects. So now let's say inside my application I need to create one object of this class X. So instead of using new, what I will do is I'll pick one object from this pool. I'll call this as object pool or memory pool. So whenever I need to create the object of this particular class X, instead of calling this new, what I will do is I'll pick one object out of this particular pool. So let's say I'm calling this object as object 1. And let's say I need to create one more object, then I'll pick next object from here and I'll call this as object 2. So likewise, let's say at a time I need 100 objects. So I can pick 100 objects from this particular memory pool. And whenever I need to delete any object, let's say I need to delete object 1. So I'll put this particular object back to this particular memory pool. so that whenever I need to create one more object, I can reuse this particular object again. So this entire process will keep on going. So ideally at any particular point in time, my application required 100 objects and I have already created the memory for 200 objects. So almost in all the cases, I'll be able to pick 100 objects from this particular memory pool. So instead of doing this very expensive call again and again, I'll just pick the object from the pool and will put back that particular object to the pool. And this entire process is very fast as compared to creating the memory using new. So let's say fetching the object from this particular memory pool takes, let's say, 1 milliseconds, and total how many objects will be there inside my system? So total objects will be 100. So this time will be 100 milliseconds. And let's say putting back the object to the memory pool takes 0.5 milliseconds. So this time will be 50 milliseconds. So in total, this time will come out to be 150 milliseconds. So earlier when we were creating the memory using new keyword for these 100 objects, at that time the total time was 300 milliseconds. But when we are using the concept of memory pool, at that time this particular time is coming out to be 150 milliseconds. And why this is like this? So when we use new to create the memory for this particular class X, so internally our system is gonna make some kind of system call, and that system call is very expensive. And as part of that system call, inside a huge memory, my system will try to figure out where are the 4 bytes available in the memory. So it will try to, let's say the total size of the memory is 100 KB. So my system will try to figure out where are 4 bytes available for allocation. So this entire process is very expensive, like making the system call, and internally that particular system call will try to figure out where is the available memory. So that's why this entire process takes very high time as compared to using the concept of memory pool. So in any case, where we know that we need to create and destroy the objects very frequently inside our system, at that time we can go for the concept of memory pool. So in the next lecture, we'll try to have theoretical understanding of how we can implement memory pool and what is the core idea behind implementation. I hope this particular lecture was helpful for you. So let's meet in the next lecture. Thank you.